What's up, DIY Adventures fans? You already know what it is, man. We're back with another video, and this video today is a little bit different. Today we're on the teaching side, and y'all know if I know something, I'm gonna talk it just as it is. You already know what it is. So please don't forget to like, share, comment, subscribe. You know, I'll have more videos like this coming on a more regular basis. Now, for the past couple of months, you know, y'all see a few of my previous videos. I install a few transformers, and I be getting a lot of comments and whatsoever. But yeah, in the last few months, I installed about, I want to say 12 transformers. Now, what's happening is that a helper asked me, one of our apprentices asked me a few days ago, man, how do you know what size wire to use on the transformer? And the typical way a lot of people do it is, man, they go look on the transformer, see how many amps the transformer pull, then they go look for the wire, then they get their overcurrent protective device. But today I'm gonna show you guys the right way to get the full load amp, the minimum and maximum overcurrent protective device using the NEC codebook. And we're gonna look on article 450.3b and 240.6a. Those are the two articles we're gonna look on. Now, I write an example on the board right here, and we're gonna solve this together. And this is how you're going to find the full load amp and the overcurrent protective device for any transformer, right? Whether single phase or three phase. Right now I have a single phase problem on the board right here, and that's what we're gonna look on right here. Now, on the primary side, which is gonna feed the transformer, obviously it's a step down transformer. On the primary side we have 480, and on the secondary side we have 120. And as you can see, it's a single phase, right? We're dealing with single phase right here. The transformer is 12 kVA, so that's 12,000 volt amps. So watch this now. We're trying to find a FLA, which is the full load amps, and the maximum overcurrent protective device, and we're going to find that for the primary and the secondary, right? So let's put right here FLA for the PR, right? And we said we're doing, it's 12,000 kVA. So this is what's up. So 12,000 kVA, right? And the primary is 480 V, right? So right here, for the secondary side, it's gonna be the same thing because it's the same transformer. So it's gonna be 12,000 30. Don't watch my right, watch the information. Over the primary right here, 120 volt. My board is also small, right? And we're trying to find the FLA. So let me write this a little bit neater. Let me just write this a little bit neater. So 12,000 for 120 volt, and we're looking for the FLA for the secondary. All right. Now what you're gonna do, since it's a single phase, you're gonna get 12,000 divide by 480, is equal to 25 amps. So that's equal to 25 amps. So 25 amps right here is the full load current, right? So that's the minimum overcurrent protective device you can use from this transformer. So whatever size wire 25 amp, and you know you would verify that at 310 16B. Verify your size wire that goes with this, right? Now, because we're looking for the maximum overcurrent protective device, you have your 25 amp already. Your 25 amp. Now, you're gonna go to the code book and look for this article right here, 450.3b. And there we have the table. That's a maximum rating setting off overcurrent protective device for transformer 1000 volts or less. There's a table there, and on that table it says primary and secondary, and we're dealing with the primary side right here. It says current of 9 ampere or more, so that's what we're looking for. And if you look in the lower level here, it says primary only. No, because we're looking for primary and secondary. So with the primary and secondary, it says we should multiply by 250%. And how you're gonna write that 50% is like this. So it's gonna be 25 times 2.5, right? And when you do that 25 times 2.5, you're gonna get 62.5 amp. But I've never seen a 62.5 amp breaker yet. So what we're gonna do, back again to the article 240.6a. That's where we're gonna go. 240, article 240, that's .6a, and that's where you're gonna verify your breaker. Standard ampere rating, fuse, and inverse time breaker size. So if you look, I've never seen, there's no size in there saying 62. So because we're looking for the maximum, we're gonna use a 60 amp breaker because it's a standard size rating, right? So you could, I don't see a 65 either. What? I don't see a 65, and you don't want to make it over too much. So the maximum overcurrent protective device that we're going to use is a 60 amp. Let me use a different marker. Let me use red. So it's going to be a 60 amp for your primary. For your primary side. Roger that. Now, for the secondary side, I'm gonna just make a little space right here. So 60 amp for this side. For this side over here, we're gonna do the same as we did for the primary side. For the secondary side, since it's 120 volts, so it's 12,000 divided by 120 volt, and that gives you 100 amp. So the full load amp is equal to 100 ampere, right? Again, we're looking for the maximum overcurrent protective device. So that's gonna take us back to the article 450.3 to see if we're good. So 450.3 450.4, 450.3B, right? And then you're gonna look, it's over 9 ampere. You're gonna look in the same side beside the primary and look into the secondary, and you're gonna multiply it by 1.25 because you're doing primary and secondary. So that would be 100 times 100 amp times 1.25, right? That's 125%. So 100 times 1.25 is equal to 125 amp. So that's equal to 125 amp. So that's your maximum overcurrent protective device. But what we're gonna do right here is that we're gonna go back to 240.6A, 240.6A to verify the breaker. So I said it was 125 amp. Yep, that's a standard rating. So your maximum overcurrent protective device is your FLA is 100 amp, maximum 125 amp, and this right here 25 amp and 60 amp. That's how you find your wire size, breaker size for a transformer, single phase, primary and secondary. All right, so if you have any questions, please leave it down in the description. As I said, if I know how, I'm gonna tell you how. Not the smartest guy around town, but I've been over a few stumbling blocks before and I know a little bit. All right, so thanks for watching. Watch the follow-up video for the 3-phase calculation because it's a little bit different. We're gonna use the same scenario, same 12 kVA but the formula is a bit different. So stay tuned for part 2 of this video.